Let's consider surds in trigonometry. Let's find x in this right angle triangle. To find any side on a right angle triangle without considering the internal angles, we apply Pythagoras theorem. This theorem states that we have to identify the longest side of the right angle. The longest side of the right angle is the side that is facing the right angle, and here it is x. Next, we are going to square the value of that longest side. Next, we are going to square the both remaining side and sum the both of them. That is, here we are going to have 2 squared, and here we are going to have 4 squared, and we are going to add the both remaining sides. We have applied Pythagoras theorem to enable us to find x. Next, this is x squared. 2 squared is 4 plus 4 squared is 16. Next, we're going to have x squared is 20. This is x squared, but we are looking for x. On the other side, we have 20. When this square moves across, it becomes the square root of 20. Next, what are the factors of 20? Here, we are going to draw a line and write 20. We'll start with 2. 2 into 20 is 10. 2 can go into 10, 5. 2 cannot go into 5 without a remainder. 3 cannot go without a remainder. 4 cannot go without a remainder. But 5 can go into 5, 1. Once we get 1, we stop. Next, we are going to pair. 2 got a pair. And here, we are going to write these 2 out because 2 here is free. However, this 5 got no pair. We are going to put this 5 inside the square root. That means the square root of 20 is the same thing as 2 root 5. Hence, our x becomes 2 the square root of 5. This length is in meters, and this length is in meters. This will be in meters. And we have found the value of our x in surd form. We applied Pythagoras theorem because the internal angles are not our concern. Let's find the value of y, which is the length of this side. The first thing you will observe is this is a right angle triangle. Next, we're going to identify the longest side. The longest side is y. And for the square root of 18, the square root of 18 is, we draw a line and write 18. Another way I can say this is 18, and what are all the factors of 18 that can divide 18 without remainder? It is 2, it is 3, it is 6, it is 9, it is also 18. Next, we ask ourselves, which among these factors, when we put them together, will give us 18? 2 times 3 cannot give us 18. 6 times 9 cannot give us 18. It is only 2 times 9 that will give us 18. Next, we're going to apply the law of surd that says the square root of 2 times the square root of 9. Here we are going to have the square root of 9 is 3, and this will remain in its square root. Instead of using this, I can use this by saying 2 will go into 18 and we're going to have 9. 2 cannot go into 9 without a remainder. I will go with 3. 3 into 9 is 3, and 3 into 3 is 1. Next, I will pair. This 3 got a pair. 3 is free. 2 got no pair. I will put it inside the square root. 3 multiplied by the square root of 2 will give you the square root of 18. This is in surd form, which we obtained here. You can use this method, or you can use this method to find the square root of 18. Next, here I will write 3 root 2 centimeters instead of the square root of 18. Next, according to Pythagoras, I will write the longest side and square it. Next, I will sum the both sides remaining, and here I have 3 root 2 also squared. Next, this is y squared and this is 4 plus, according to the law of indices, if I have AB all to the power of n, this is A to the power of n and B to the power of n. I'm going to apply this law to this. I'm going to have 3 to the power of 2 and the square root of 2 all to the power of 2 according to this law. This is y squared and here is 4 plus this is 9, and it will multiply. This is the same thing as 2 to the power of 1 over 2. The square root of any number or variable is the same thing as that variable to the power of 1 over 2. The square root of 2 is the same thing as 2 to the power of 1 over 2. That's what I've just done here. And this got a squared. Next, these 2 we take away these 2, and we are left with y squared is 4 plus 9 times 2. This 9 will multiply these 2, and we have y squared is 4 plus 18. Y squared is 4 plus 18 will give you 22. Here, our y is now the square root of 22. Next, let's try to break down 22 into its factors. 2 can go into 22 without a remainder. 3 cannot go. 4 cannot go. But 11 can go into 22 without a remainder. 22 can also go into 22 without a remainder. There are no 2 combinations that will give us 22 here. The square root of 22 cannot be broken down any further in surd form, and we're going to leave our answer here. Centimeters, because we have centimeters as the length. We have found the value of our y, leaving our answer in surd form. Let's find the value of x in this right angle triangle. Because we are not concerned about the internal angles, we're going to consider Pythagoras' theorem. The first step is to identify the longest side. The longest side is the side facing the right angle, and here we're going to write x squared. Next, we're going to square each of this on the other side, and I'm going to have the square root of 15 minus the square root of 3 all squared plus I'm going to square this as well. The square root of 15 plus the square root of 3, all squared. This is Pythagoras theorem. Next, this is x squared. I'm going to open this bracket twice. That's the meaning of the squared. Likewise, I will open this up twice. That means this is now this. Likewise, this becomes this. Next, we're going to expand this bracket. Here we have x squared. The square root of 15 multiplied by the square root of 15. We are going to have the square root of 225. The square root of 225 will return only 15. The square root of 15 multiplied by the square root of 15 will return only 15. Next, the square root of 15 will multiply minus the square root of 3. Plus times minus will give you a minus. This is square root of 15. Inside the bracket, this 3 will also multiply. And here, we're going to have the square root of 45. According to the law of Surds, this will become the square root of 45. Next, minus the square root of 3 will multiply this square root of 15. This is a minus. We are going to have the square root of 45. Next, minus the square root of 3 will multiply minus the square root of 3. Minus times minus will give us plus. Inside the square root, 3 will multiply 3, and we're going to have the square root of 9. The square root of 9 will return 3. Here, I will have only 3. And I will write 3 here. Now, I am done with this bracket. Next, I will have this plus. The square root of 15 will multiply the square root of 15. And we are going to have only 15. The square root of 15 will multiply the square root of 3. Here, we are going to have the square root of 45. The square root of 3 will multiply the square root of 15. We are going to have the square root of 45. Next, the square root of 3 will multiply the square root of 3. And here, we are going to be left with only 3. Next, minus the square root of 45. We cancel plus the square root of 45. Next, minus the square root of 45. We cancel plus the square root of 45. Next, here we have x squared. 15 plus 15 is 30. 30 plus 3 is 33. And 33 plus 3 will give you 36. Next, we need the value of x only. On this side, we have 36. This squared will move across and become a square root. And x is the square root of 36 is 6. The value of the longest side is 6. And because we are not given any units, either centimeters or inches or millimeters, you are not going to include anyone. Our final answer is just 6. Let's find the value of x and the value of h. If you consider this right angle triangle, we don't know here, we don't know here, but we know this part. We have 2 unknown on this side. But if you consider this right angle triangle, we have the value of this side and we also have the value of this side. That means we can easily find h. And when we get h, it is easy to find x. Because the internal angles is not our concern. We're going to consider Pythagoras theorem. The first step is to consider this first part of the right angle triangle. Here is the first part. When we are done with this, we can now consider the second part. The first step is to identify the longest side in this right angle triangle. The longest side is the side facing the right angle, which is 2 multiplied by the square root of 5. I will write 2 the square root of 5 all squared. Next, I will sum the both remaining side. Here I have 3 root 2 all squared. Next, this is 2 squared, and this will give us 5 to the power of 1 over 2 all squared. Here I have h squared plus this is 3 to the power of 2. This is 2 to the power of 1 over 2, which is the same thing as the square root of 2 all squared. Next, this 2 we take away this 2. Likewise, this 2 we cancel this 2. Here we are going to have 4 for 2 squared times 5. Here we have h squared plus this is 9 times 2. This is 20. Here we have h squared plus 18. Next, I'm looking for h. H squared will be here. On this side, I have 20. 18 will move across. Because it is plus, on the other side is going to be minus 18. Next, this is h squared is 2. H is the square root of 2. And the unit is in centimeters. We have obtained the value of this height, which is the square root of 2. Now we can consider this right angle triangle because we have the value of our h, we also have the value of this length. We can find x now. To find x, the longest side is the side facing the right angle, which is x, and here we are going to square the x. Next, we are going to sum these two remaining sides. This is the square root of 2 all squared plus this is the square root of 2 all squared. Next, this is x squared. The square root of 2 is 2 to the power of 1 over 2, and we have a square outside, plus this is the square root of 2, and here we have a square at the top. Next, this 2 we take away this 2, and this 2 we also take away this 2. Next, we are left with x squared is 2 plus 2, and we have that x is the square root of 4, and here our x is 2, and the unit is centimeters. We have found the value of our x. Likewise, we have found the value of our h, and we are done with the solution. Let's find the angle theta in this right angle triangle. When angles are involved in a right angle triangle, you should not think of Pythagoras theorem. You won't be using Pythagoras theorem. You will think of SOHCAHTOA. The first step is to identify the opposite. Here, the opposite is the side facing the angle, which is √3/2. Next, you identify the longest length. The longest side is the side facing the right angle, which is the hypotenuse. And this remaining part is the adjacent. Here we have the opposite and the hypotenuse. We don't know the adjacent. We can only use Pythagoras theorem if we are looking for this side. But our aim is to find this angle. Cos have adjacent. I will not use cos. Tan has adjacent. I will not use tan. I will go for sine of the angle because it has opposite and it also has the hypotenuse here. Then I won't make use of this. I will go for the sine of the angle. Then sine of the angle is opposite, which is √3 divided by 2. Then divide by the square root of 5. Next, we're going to have that this is sine theta divided by the square root of 3 divided by 2 divide by the square root of 5. Sine theta is the square root of 3 divided by 2 times 1 over the square root of 5. Here we're going to have that sine theta is the square root of 3 divided by 2 multiplied by the square root of 5. Next, we're going to have that our angle theta is this sine will move across and become the sine inverse of the square root of 3 divided by 2 multiplied by the square root of 5 in brackets. If you decide to rationalize this so that you have the square root of 3 divided by 2 multiplied by the square root of 5 times 2√5 divide 2√5. This times this will give you 2√15 divided by this times this is 4 and this times this will give you 5. This 2 will take away this 4 and you are going to have the square root of 15 divide by 2 times 5. Here we are going to have the square root of 15 divide by 10. Then this angle theta will become the sine inverse of √15 divide by 10. We have rationalized the denominator. Then this becomes theta is the sine inverse of the square root of 15 divided by 10. This becomes the angle in surd form, which is this angle, and this becomes our answer. In this question, you are not meant to use a calculator. Let's find the angle x. To find the angle inside a right angle triangle, we are going to consider SOHCAHTOA. The first step is to identify the opposite. Here, the opposite is not given. Next, we are going to identify the hypotenuse. The hypotenuse is the side facing this right angle. Here, it is the square root of 2. Next, the adjacent automatically becomes the remaining side, which is the square root of 6. This is step number 2. Step number 1 is identifying the formula to use to find the angle. The next step is to recognize that the opposite, which is this side, is not given. In this SOHCAHTOA, sine got opposite. Then I will not use sine. Tan also has opposite. I will not use tan. I will go for cosine because it has adjacent and hypotenuse. Then the cosine of this angle x is adjacent, which is the square root of 6 divided by the hypotenuse, which is the square root of 2. Next, here I will have that cos x is, I'm going to rationalize this to have the square root of 2 times the square root of 2. Next, I will have that cos x is this times this will give you the square root of 12 divided by root 2 times root 2 will give you 2. Next, we are looking for the angle x. Cos will move across and become cos inverse of the square root of 12 divided by 2. Next, the square root of 12 can be splitted down to have 12. 2 will go into 12. 6. 2 will go into 6. 3. And 3 will go into 3. 1. Next, these 2 got pair. 2 is free. 3 has no pair, and we'll put it in root form. 2 multiplied by the square root of 3 is the same thing as the square root of 12. Another way you can do this is thinking of all the factors of 12. We have 2, we have 3, we have 6, we have 4, and we also have 12. 2 can go into 12 without a remainder. 3 can go into 12 without a remainder. 4 can go into 12 without a remainder. 6 can go into 12 without a remainder. And 12 can go into 12 without a remainder. But which of these combinations, when we multiply them, will give us 12? 2 times 3 can give us 12. 3 times 4 can give us 12. And 2 times 6 can also give us 12. If we decide to use 3 times 4, which is the same thing as the square root of 12, we can apply the law of Surds that says the square root of 3 times the square root of 4. The square root of 4 is 2, and this is root 3. And if we decide to go with 2 times 6, we are going to have root 2 times root 6. And we are going to have root 2 times root 2 times root 3. Because inside this, I can have 2 times 3 to give us 6. And here, I have root 2 times root 2 is 2. And here, I have root 3. If you decide to go with this method, this is fine. And if you decide to go with this method, this is also fine. But in place of the square root of 12, I'm going to have 2 multiplied by the square root of 3. And our x becomes the cos inverse of 2 multiplied by the square root of 3 divided by 2 in bracket. Next, these 2, we take away these 2. And our x becomes the cos inverse of the square root of 3, leaving your answer in surd form without the use of calculator. Let's find this length y in meters. In this triangle, this is not a right angle triangle. You cannot think of Pythagoras theorem and you cannot think of SOHCAHTOA because we have 3 sides, which only 2 are known, but one side is unknown, and we have one given angle. In such a case, you can only apply cosine rule, and cosine rule states that you identify the given angle, the side facing the given angle. We are going to have that side facing the angle squared is the sum of the other squared of the remaining side multiply by 2 times the side times cosine of the given angle. We are going to apply this rule to this question. That is, I will start with the side facing the angle. I will square it. The 2 remaining side, which is the square root of 3 and the square root of 2. I will square both of them and add them. Next, minus 2 multiply by this square root of 3 multiply by this square root of 2 multiply by the cosine of the angle under consideration. This is the cosine rule. Next, we're going to have y to the power of 1 over 2 all squared. This y to the power of 1 over 2 is the same thing as the square root of y. And here, 3 to the power of 1 over 2 is the same thing as the square root of 3 squared. Plus, this is 2 to the power of 1 over 2 all squared. Minus, this is 2 times the square root of 3 times the square root of 2 times cosine of the angle, which is 60 degrees. Next, these 2 we take away these 2. These 2 we take away these 2. And these 2 we take away these 2. Here we are left with y is 3 plus 2 minus 2 the square root of 3 times, inside the square root we are going to multiply this, then times, instead of cos 60 I will have 1 over 2 from the special angle formula. Y is 5 minus 2 times 1 over 2 times the square root of 6. Here, 2 we take away 2, and y is 5 minus the square root of 6. And this becomes the value of our y, which is the length of this side in meters, which is the given unit. We have left our answer in surd form without the use of a calculator. Let's find the value of this length, x. The first thing to observe is that this is not a right angle triangle. We cannot think of Pythagoras theorem or SOHCAHTOA, which are usually used for a right angle triangle. Here we have 2 sides given, but only one side is known in these 2 sides, while the other side is unknown. And we also have two angles, and these two angles are known. In this condition, where you have two known angles, one known side and one unknown, then you should think of sine rule. Sine rule states that the sine of this considered angle divided by the side it's facing, which is x, is equal to the sine of the other angle divided by this side it is facing, which is root 3 divided by 3. We have applied the sine rule. Next, this will multiply this, and we're going to have root 3 divided by 3 times sine 30 degrees. This will multiply this by cross multiplication, and we're going to have x times sine 45. Next, we are looking for x. Then we're going to have the square root of 3 divided by 3 times sine 30 degrees. Here we are going to be left with only x. Sine 45 will come down to divide. Next, we're going to simplify this, and here we're going to have that root 3 divided by 3 times sine 30 is 1 over 2 divided by sine 45 is root 2 over 2. When you rationalize 1 over the square root of 2, you are going to get the square root of 2 divided by 2 for sine 45. Next, we are going to have root 3 divided by 3 times 2 is 6. Divide root 2 divided by 2. Here, we are going to have root 3 divided by 6 times 2 divided by the square root of 2. 2 here is 1 and 2 here is 3. Here, we now have the square root of 3 divided by 3 root 2. Next, we are going to have the square root of 3 divided by 3 root 2. We are going to rationalize to have 3 root 2 divided by 3 root 2. This will give us 3 multiplied by the square root of 3 times 2 is 6. Divided by 3 times 3 is 9, and root 2 times root 2 is 2. 3 here is 1 and 3 here is 3. Here we are going to have root 6 divided by 3 times 2 is 6. You see, we have simplified all this to become the square root of 6 divided by 6. I'm going to input this answer, which we obtain by simplifying this, and I will have that x is the square root of 6 divided by 6, and this becomes our answer in meters. It is important to know when to apply Pythagoras theorem or SOHCAHTOA or the sine rule or the cosine rule, because this is an important skill when solving problems in trigonometry.